Hello everybody. We are talking about ellipses today, and so it's our next shape within our conic sections. So far we've talked about circles that have a center and a radius, and so that radius is the same all the way around, and the ellipse is something that's a little bit more oblong, and it has the same distance here and here. And so this is, we're going to call this B today, and this distance here and here, and those are A and A. So it's kind of like we have a short radius today and a long radius, and then a long diameter and a short diameter. So those are kind of the things that we're going to talk about today. So circles we've talked about, ellipses we've talked about it, and then these are the two shapes that will be on our next test, which is this coming Wednesday. All right, and so the ellipse is a set of points in a plane such that the sum of the distance from a point P to two fixed points F1 and F2 is a given constant. So basically what this means is that D1 plus D2 is always the same number. So whether I pick this point over here and add those two distances, that's going to still be the same number. If I go from here and then back to the other focus point, that is also going to be the same distance. So all the points along the edge here, it doesn't matter where I go, as long as I go focus point to focus point to the edge to focus point, it's always going to be the same distance. And so sometimes you'll see foci, so focus and foci. Foci is just the plural form of that. And so there's always two foci or two focus points for the ellipse. And so here, there's just a couple of places where you see ellipses in the world. And so this is the White House right here. And so across from the White House lawn, there is an elliptical garden park. They call it the Ellipse. And then if you were unaware, the sun is one of our focus points as our planets travel around the sun. And so thankfully on Earth, our ellipse is very, very, very circular. And so it's a very circular path that our planet travels. But the sun is one of those focus points. So it's not a circle that we travel around the sun, it is actually an ellipse. And then I took this picture in Grand Central Station, and so you can kind of see the ceiling on this is an ellipse. And so in one corner, it is a focus point because it's a very long ellipse, very stretched out. It's very stretched out. And so then I'm standing in the other ellipse corner, or the other focus point corner. And so when you stand in the corner and you talk, the sound, because of the way the shape is, like we drew here, the sound, if you stand in the focus point, the sound goes straight to the ceiling and then to the other focus point. And so it's a very direct path for the sound wave to travel, and they call it a whispering gallery. And so in the basement of Grand Central Station, there's a whispering gallery, and so that's just some of the cool things where you can see ellipses happen in the world. Okay, so we have, I kind of alluded to this earlier, we have a short radius or a short diameter. That's what we call the minor axis. The minor axis is all the way across. And then if we're just going halfway, so kind of like a radius length, this is your semi-minor axis. And then if we're going the other direction, this is my major axis all the way across, but just halfway would be semi-major. So the minor is the short, major is the long. And then the endpoints of the major axis, those are called the vertices. And then for the endpoints of the minor axis, those would be our co-vertices here. So C and D would be co-vertices, A and B would be vertices. And so there's just a lot of vocabulary. So you may need to pause the video here and write some of this down, or draw your picture and label your picture if that's easier instead of writing. But you need to know those vocabulary words. So semi-major is like a radius, semi-minor is like the short radius, and then so the semi in front is like the radius length, and then major or minor is all the way across. So it's kind of like your short diameter and your long diameter. Okay, and so we can talk about two different forms. You've seen this if you've been doing your assignment. When we did some completing the square, we always started in the general form, and we didn't ever have this term when we were doing completing the square. And so we started in general form, and then we ended up in standard form. And so we will get to some completing the square soon, but not yet. So today we're just worried about, like, okay, if we're in standard form, what does the H and the K control? What does the A and the B control? And so this is the standard form. So it looks very similar to the circle, except now we have two different values that are controlling the long radius and the short radius. Okay, and so for our A and our B, A is the horizontal distance, and B is the vertical distance. And so if we go back to this equation, so A is this distance here, and B is this distance up and down in this format. And so A is always with my X value, and so that's my horizontal radius. And so the A and the B are the semi-major and the semi-minor. And so it may not always be A is the semi-major, B is the semi-minor. What it always is A is the value that's horizontal, B is the value that is vertical. And so depending on what textbook or what website or whatever you're using, some websites like switch the A and the B, and I just think that's confusing. And so I'm trying to simplify it for us a little bit. And so whichever of these numbers is bigger when we are trying to find the focal length, so C is my focal length, that is the distance from the center to the focus point. So this distance here is C, and this distance here is C. And so the way that we come up with this C value is we take the larger number, and so in this case A is larger, and so it's the bigger number squared, so the bigger denominator minus the smaller denominator, and then we can square root it because it's kind of like Pythagorean theorem. It looks sort of like Pythagorean theorem, and so C is equal to the square root of the bigger denominator minus the smaller denominator. And so that's where C is coming from here. Alrighty, so let's get into some numbers and see if we can make some sense of this. So here, my center is going to behave just like my center did before. So there's nothing being added or subtracted on the X or the Y, and so this is going to be 0, 0. My vertices are the major axis. So we're going left and right because this number is with X, and we want the square root of 36, which is 6. We want the square root of 16, which is 4. So A is 6, B is 4, and so from the center, I am going left 6 and right 6 to get to my vertices. So that's going to be 6, 0, and negative 6, 0. And my co-vertices, because the 4 is shorter, and the 4 is with Y, we're going up and down. So that means it's going to change my Y value. So 0, 4, and 0, negative 4. And so I'm going to graph some of these points for us. So we have our center at 0, 0. We have our vertices. I'm going to label these a little bit. So vertex, vertex, and then my co-vertices, I'll change colors here, are going up 4 and down 4. And so this is a co-vertice, this is a co-vertice. And then, as poorly as I can, kind of looks like a potato. But it's a little bit longer on the horizontal axis than it is on the vertical axis. Okay, so now our foci. So we're always doing bigger squared minus smaller squared. So this one would be C is equal to the bigger number, bigger denominator. So 36, because it's already squared, we don't need to square it again, minus 16. And so this is going to be the square root of 20. And that is approximately 4.47. So I'm going 4.7 away from my center. So 1, 2, 3, 4.7. That is a focus point. And 4.7, that is a focus point. And so this is my focal length from the center. And so the focus points, what the focus points are doing is it's kind of like as soon as those focus points separate, it's stretching my graph either horizontally or vertically, depending on which one has the major axis. And so it's like stretching out my graph, stretching out my picture here. Okay, and so let's go back to talk about eccentricity. The other day I talked about eccentricity, and it's really like how circular the graph is. And so it's the ratio of the focal length to the semi-major axis. So if we're looking at this picture, it's the relationship between this distance from the center to the vertex and the center to the focus point. So it's like the closer that is, the closer the focus point moves toward the vertex, the bigger that number is going to be. So the more stretched out it's going to be, the higher that eccentricity is going to be. And so this is E, we'll leave it. E is equal to C over A. And so my C value is 4.47 over my A value, or the bigger number, which is 6. And so this is going to be 4.47 divided by 6. And so that would be 0.75. The major axis is twice the length of my longer axis, so this would be 12. And my minor axis is twice the length of my semi-minor, and so that one is going to be 8. I will have another video with another example, but that is going to be where I stop here.